Hey everyone, thanks for tuning in. Really appreciate you joining us today. Today we'll be talking about GitOps in the context of GitLab and Anthos Config Management. So really looking to talk about in more detail on how organizations can adopt GitOps, the cultural aspect of it, with the right technology toolsets like GitLab and Anthos. My name is Mike Daldramani. I'm a Senior Alliance Manager here at GitLab, and I've had the privilege to work with many different teams across Google to bring to market how GitLab and Anthos are lowering the barrier of entry into DevOps and cloud-native best practices for our customers. I'll pass it to Theo to do a quick intro.
Hi, everyone. Super happy to be here. I'm Theo Chamlet. I'm a cloud solutions architect for Google Cloud, and I work on various DevOps topics, and I happen to be a fairly heavy GitLab user. Back to you, Mayank.
Brilliant. So before we dive into the joint solution, let's talk about the core building blocks of what we're discussing, give a little bit of context and background, particularly around the core building block of Kubernetes as a robust platform as a service to manage all your container workloads. As companies look to move into microservice-based architecture and containerize their application, Kubernetes becomes the de facto platform to deploy to. And as organizations grow and complexity arises, you can imagine more and more Kubernetes clusters across hybrid or multi-cloud environments become the de facto norm. So to manage that complexity, whether it's across policy management, networking, managing different clusters, all of that complexity can be addressed with Anthos as a solution. Anthos is a unified platform. It's managed, applicable for multi and hybrid cloud environments that are running Kubernetes workloads, particularly with Anthos Config Management that we'll be focusing on today's talk on how you can manage those policies and declarative code to manage complexity across your different clusters and environments. On top of Anthos is GitLab, which helps you provide that workflow management capability in a single application for your operators, your developers, for your security engineers, a single pane of glass where they can all work, store their code, and provide information concurrently and collaboratively as a single source of truth, a single DevOps application that can help you manage how you operate and deploy to across Kubernetes clusters using Anthos. But that's the technology aspect of it. Let's also talk about the cultural aspect of it. Why even go down the route of declarative infrastructure, declarative code to operate your complexity? Why GitOps in general? Really, with GitOps, you get a lot of reliability. Once you've defined it and fully automated the process, you're able to replicate it in a reliable fashion. The more you software define your operations, the more you software define your business, the less human intervention that you have to work with. You abstract and allow humans to focus on the intellectual contributions to your iterations and improvements versus having error-prone processes where different teams are having to communicate with each other through asynchronous or different means that are not automated. Accessibility becomes also another great value proposition of GitOps. Once it's in Git, it's versioned, it's a source of truth. You can track the change. You can concurrently collaborate as things are being ported, changed, and redeployed. You can track those changes over time using Git as a fundamental protocol and then using GitLab for the workflow aspect of it. At the end of the day, you're using familiar tools when you're trying to adopt GitOps. You're using Kubernetes manifest, you're using YAMLs, that's much more declarative and explicit. You're using CI/CD and merge requests in GitLab. And you're using Git, allowing more user personas in the single pane of glass to operate familiar tools that developers are already familiar with today. So let's now dive into the reference architecture. How do we configure GitLab and your repositories to work better, to work seamlessly with Anthos Config Management? Theo, do you mind walking us through the slide?
Yeah, sure. Thanks, Mayank. So really here, this is our reference architecture. On the right, you have two Google Kubernetes engine, one staging and one for production. You, of course, can have more than that, but that's just our example. And in the center here, in that gray box, we have the core of the system, which is GitLab. And we are using GitLab to host 3 different Git repositories. And the first one that I want to talk about is the one with in the middle with the black logo. It's called Anthos Config Management. And that's a Git repository that's going to be mainly used by the platform teams. And the goal of Anthos Config Management is to bring a GitOps approach to config and policies. So with that repository, when you commit a config to that repository, you will be able to automatically apply that configuration or that policy across all your clusters at once. And because it's in a Git repository and because it's declarative, you can use all the usual Git workflows and GitLab workflows that you're used to, such as merge requests or approvals or CI tests, etc., etc., etc. And on the left, we have two other Git repositories that are used for the last component of this reference architecture. This last component is Application Delivery Manager, or AppCTL for short, which is the name of the CLI. And so we had Anthos Config Management, that's GitOps for config and policies, and we have AppCTL, that's GitOps for applications. So the first of those two Git repositories, that's the one with the red logo, that's the application repository. And that's really a normal application repository. In our case, it's called Hello World because I'm a fairly bad developer, but it's really a normal Git repository where you have your source code, be it Java, Python, Ruby, whatever you want. The only difference is that you have basically templates for your Kubernetes configurations in that repository. And in that repository, you work as you would normally. And the last repository is the one with the yellow logo. It's called the deployment repository. And that one is mainly managed by AppCTL. You don't have to interact with it too much. And the only thing that it contains is the fully built Kubernetes configurations that are built from the templates that are in the first repository, the application repository. And so that last repository, the deployment one, contains those full Kubernetes configurations for each environment. And AppCTL is going to apply those as is to your different Kubernetes clusters. So let's deep dive into the first of those components that I mentioned, Anthos Config Management. So just to preface everything, Anthos Config Management is part of Anthos and is a globally available product today. So it actually has three different subcomponents. The first of those is called config sync. And config sync is taking the configurations and policies and everything that you have in your Git repository and applying that to your Kubernetes clusters. And really, it can be any Kubernetes objects, but we're focusing on config and policies and things like RBAC roles or Istio security rules or network policies, those kind of things. The second of those components is called Policy Controller, and that's a managed version of an open source project called Open Policy Agent Gatekeeper. And Policy Controller allows you to enforce policies across all of your clusters. So for example, if you want all your deployments to be labeled with an owner label, allowing you to identify which team owns which deployment, then you can enforce that with Policy Controller. You just declare the policy in your Git repository, and every time that a deployment is going to be created, Policy Controller is going to allow that creation or not, depending on what you have in your deployment. And the last component that I'm not actually going to demo today is called Config Connector, and that makes the link between Kubernetes custom resources and GCP resources. So for example, you can have a Cloud SQL custom resource in Kubernetes, and Config Connector is going to create and manage for you the corresponding Cloud SQL instance in GCP. And between config sync and config connector, you can declare your GCP resources in your Git repository and have them created and managed in GCP. So let's move to the next component, which is application delivery, aka AppCTL. So AppCTL is not yet a GA product, it's pre-release, it's freely available, and we're actively looking for user feedback on that product to make it even better and even more flexible for the users. So as I mentioned previously, AppCTL really works with two Git repositories. On the left here with the red logo, we have the application repository. And it's really a normal application repository where you're going to develop, you're going to create commits, create branches, create merge requests in GitLab, and have a peer review on that merge request, run CI test, etc., etc. And once that merge request is approved, you're going to merge it back on the main branch that it's called master here. And once you want to release your application to your various environments, you're going to tag a specific commit, in our case, 1, 2, 3. At that stage, you can run the command appctl prepare staging. And what that does, looks at your application repository, takes the last state of that, and builds the full Kubernetes configurations for that version of your application, and creates a merge request in the deployment repository on the right here with the yellow logo, with that full Kubernetes configuration. And because it's a merge request, you can review it. You can run a CI test in GitLab CI on that merge request, all the normal things. And really, it allows you to see exactly what's going to be deployed in staging. And once you're fine with that, you actually merge that onto the staging branch, and you run appctl apply staging, and that's actually going to deploy your application in staging. And you can see that in that repository, on the deployment one on the right, we have multiple branches, and we have actually one branch per environment, one for the staging environment, one for the prod environment, and one for other environments if you have other environments. And the last thing that we want to do is promote our application from the staging environment to the production environment. And for that, we're going to run the command appctl prepare prod from env staging. And appctl is going to look at the version that you currently have in staging, build the full Kubernetes configurations for prod, but with the version used in staging, and create a merge request for the prod branch that you're going to be able to review, test, etc., etc. And once you merge that merge request, you can run appctl apply prod, and that's going to deploy your application in production with the same version that you had in staging. So I know that all of that is a lot to take in. So I think it's better to look at a demo and to see how everything works together in reality.
We are starting with two GKE clusters, one for the production environment and one for the staging environment. As you can see, I have access to my staging cluster in that case with 3 nodes. This is the Anthos Config Management Git repository, and in this repository I can define config and policies. In this particular directory, for example, I can list my clusters and give them labels. This is also where I'm going to define my namespaces. In our case, I'm defining an hello world namespace. Just putting that namespace in that file makes it appear in my cluster. As you can see here, the hello world namespace already exists in my cluster. In that repository, I already have a merge request created for this demo. And this merge request is going to allow me to modify configurations and policies on that cluster. So for example, here, the merge request is designed to add a constraint, a policy that says that every deployment in the namespace hello world and SAM tests need to have a label called team. And for that merge request, because it's GitLab, I can just have a GitLab CI pipeline. And here I have a couple of jobs that vet that my configurations is valid, and also that validate that my own configuration is compliant with the policies that I set. To change policies, of course, you want to make sure that everyone who needs to approve a policy change is going to approve it. So in that case, we are using the approval feature of GitLab to make sure of that. And in that case, I just gave myself the approval permissions. So we are going to merge that, and you're going to see that our new policy is going to appear in the cluster fairly quickly. And here it is. So until now, I was playing the role of a platform administrator. Now let's switch and let's say that I'm a developer. I have this very simple hello world application that just displays hello world, potentially with a custom message. And it's written in Python, and I have a Docker file, everything very normal. And I have a CI pipeline for that application. And I'm going to use appctl to deploy that application. So I initialize my project with appctl, and it's actually going to create a new project, hello world deployment, that's going to contain my configurations that we're going to deploy to my clusters. And in my project now, you can see that I have 2 new directories, one for called delivery and one called config. I'm now initializing my 2 environments for appctl, so I can start by adding the staging environment by specifying which cluster and which namespace I want to deploy my staging application in, and then I just do the same thing for the prod environment. Once this is done, both environments are going to show up in the delivery directory. Here you can see just the definition of the production environment. Now, the config directory is a customized config directory, and you can see that appctl has provided a skeleton for my environments. To make things simpler, I'm just going to copy an existing configuration, and you can see that now I have a deployment where I don't specify the image tag, and a service file where I create a load balancer. And in the customization file for my base configuration, I'm going to modify the tag that I'm going to use. I'm just going to use v0.0.1, and I'm referencing the resources deployment and service. And now for each environment, I'm modifying the message, I'm giving it a custom message. Here you can see for the staging environment, I'm saying hello staging world. Now let's commit, tag, and push everything to GitLab. And obviously, this is going to trigger a CI pipeline. That CI pipeline has several stages, including one with 3 different tests. And if we look at, for example, the unit test, or in this case, the linting, we are going to see that GitLab detects some problems with my code, which we don't care too much about right now. And here you can see the unit tests that have all passed. That is important. But you can see that there's like a third test that hasn't succeeded, and that's the validate stage. And what does that stage do? As you can see, we have here policy evaluation, the same one that we saw earlier, where it says that all deployments must have a team label. And where does that come from? It actually comes from the previous stage, where we downloaded the policies from the Anthos Config Management repository. And how do I do that? If we take a look at my GitLab CI YAML file, you can see that I actually include another GitLab CI YAML file that comes from the Anthos Config Management. So the platform team has provided me already with everything that I need to check that my application is compliant with their policies. So let's fix the policy violation by adding this famous team label now. Label team hello world. We don't care too much about the actual value of the label. And now let's just update the tag, and once again commit, tag, and push everything. Of course, this creates a new CI pipeline, and spoiler alert, this one is going to actually succeed. While we're waiting for that pipeline to finish, let's use appctl to actually deploy in the staging environment. So here I'm using the appctl prepare command, and I'm saying that I want to deploy the tag v0.0.2 to the staging environment. And what does that do? It actually creates a merge request on my other repository, if you remember, the hello world deployment one. So let's take a look at that merge request. Here you can notice that I'm not in the repository for my application. I'm the hello world deployment repository. That's the one that contains the manifests that I'm going to deploy. And that merge request is a merge request to add the fully hydrated manifest to this repository. And as you can see, here in this manifest, I have an image tag and I have my custom message. And I have both my deployment and service in the same thing. And you can see that I'm actually merging into the staging branch. So appctl uses one branch per environment, and the name of the branch is the name of the environment, very, very simply. So I just merged that merge request, and in parallel, the CI pipeline on the hello world repository has finished, and we actually pushed the new image to our container registry. And now we just have to use the appctl apply staging command to actually deploy our application to the staging environment. That command is going to take what exists on the staging branch of the hello world deployment repository and is going to apply it to our cluster. So this apply command takes a little bit of time, but once it's finished, we actually have a new application in the Applications tabs of Google Kubernetes Engine. Here you can see my Hello World application in the staging cluster. For now it's empty, but very soon we are going to see the different components as you just here, service and deployment. And you can see that we have like a very specific version of that application that is shown. And if we look at our Hello World namespace, you're going to see the Hello World deployment and the job that has deployed that thing. And now we can just look at the Hello World service and at the load balancer. This is just a little bit sped up because we're waiting for the load balancer to come on. While waiting for the load balancer to come on, we are going to actually prepare our deployment to production. And in that case, we're not going to deploy from a tag, but we're going to deploy from the staging environment, meaning that we're going to promote the version that we have in staging to the production environment. And it's just the from env parameter instead of from tag. And like before, it creates a merge request in the Hello World deployment repository, the one that contains my iterated configuration. And in that case, we are going to merge onto the production branch, the prod branch, and not the staging one. And in my fully iterated manifest, I'm indeed using the same version of my application, but now I have a different custom message. So let's merge. And in the meantime, the load balancer probably has been created. Yes, here you can see it with the staging custom message. Now let's apply our newly updated configuration to the prod environment. And that's exactly the same process as for the staging environment. appctl is going to take the tip of the prod branch in the Hello World deployment repository and apply it. And we're going to have a new application in the applications page of GKE. And it's going to be exactly the same thing as for staging. Here we have our new application. And let's take a look at the service for that new application. It's, of course, in the Hello World namespace in the prod cluster. And let's refresh to get the actual IP of the service. And here we have our service with the production custom message.
Brilliant. Theo, thanks for that demo. Now that we've seen the solution live and in the demo, let's take a half step back to really recap some key takeaways. Really answer that question, why GitLab and Anthos for GitOps? As mentioned earlier, Google and GitLab are partnering together to really lower that barrier of entry into the GitOps workflows, particularly for those companies that are standardizing on Kubernetes, trying to manage their complexity, trying to software define their business to be more iterative and agile. As they explore best practices, Git becomes a fundamental building block to kind of provide that audit trail, provide that coherent cohesivity as a single source of truth. Using GitLab as a single application just beyond Git, with the approval workflows, with merge requests, automation pipeline, you get a single application with a user interface and user experience for all the different users and organization BUs that are invested in continually improving the business through software-defined means. Why limit declarative management to app and only infrastructure? Look into policy management as well, as Theo demonstrated with Anthos Config Management. Use the power of Git to manage your configs and policies while enforcing strong security posture. Really, with GitLab and Anthos, you get a full developer experience, a full DevOps experience in a unified platform. You standardize on a single DevOps tool, a single DevOps application on top of an open and unified platform that your company can adopt quickly. At this point, you're probably wondering, well, how do you get started? Where to begin? Great news is we are partnering with SADA and Arctic as channel partners that can help guide you through that process and really help you adopt what you saw here today. Alternatively, we do have reference material that you can check out offline. We've got 2 solution guides that are readily available today where you can see and read more about the best practices on how to architect that application repository that Theo was mentioning, where you store your config policies for your multiple clusters. This is a solution paper that Theo actually wrote, so definitely check it out to get more finer detail on how you build up that repository. Additionally, we've got another solution paper live now that helps you and outlines how you can deploy GitLab on-prem on a GKE on-prem cluster that may be managed by Anthos. So if you're looking to get started in a hybrid environment, that might be a great solution paper to check out. Additionally, we've got a lot of documentation available as well on Anthos Config Management in general on Google Stocks page, as well as finer details on the appctl utility on how to use it. We've got documentation on GitLab, on best practices, on what the GitLab flow looks like, how to make most of merge requests, and how to architect different repositories and CI/CD pipelines for your use case so you can be flexible and nimble. We do have supplementary videos to this session, which have a broader perspective on how you can use GitLab and Anthos in general. So feel free to check that out as well. So with that being said, I want to thank everyone for tuning in. Thank you for your time and hope you enjoyed this session. Hope to hear from you soon. Cheers.